Okay, let's see. We have the new program counter. I put the LEDs back on after I desoldered them. Found out it was okay. Soldered it back on. So let's go ahead and insert that where it's supposed to live, right there. And we have the increment, and we have write and read and clear. So let's just tie those all high for now. So we're not going to clear, we're not going to read, and we're not going to write. So those are all high. And we have the increment floating. And the reason I want the increment floating is I'm going to run it directly off the 555 and see if it really counts correctly. So let me find a wire here so I can extend it. There we go. So I can touch it to the, can you see that? No, you can't see that. Widen it out a bit. Okay. So here's the LED counter, and here is the 555, and there's an output pin, so it's just a square wave coming out of the 555. So let's power on this thing and see if we can, there we go, get it to count. Okay, it's kind of flickering because this is kind of wiggling in the breeze. So let me hold it on out. And there we go. Hope you can see that, but it appears as though it's counting perfectly fine. Let me see if I can slow it down even farther. Let's see here, out. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so the counter is counting perfectly fine. Alright. So, next step will be, now that we know that we're counting correctly, we know that we can assert the bus because we did that last time. We took the output of this and put it onto the... oh, we weren't actually quite sure about that. So we need to make sure that we're counting correctly and then outputting that value onto the bus. So that's a little more difficult to do. We do have a bus monitor. I don't think anything's talking to the bus right now. I could try to assert this onto the bus, but I think we'll do that with the program. I'll run a program to oh, wait a minute, I think we actually have that program running. Let me reset this thing so it's address 0. There we go. And let's see if we can get this to work. Well, it is counting. I don't see it asserting the bus. Oh, I know, because we didn't have these lines hooked up. Alright, let's turn this off for a second. Okay, so we have write. Write is a from device. Let's see, write is a to device. So, to PC write right here. Okay. And then we have read. Read is PC read, that there. And clear is, we'll leave that high again. Alright. Okay, let's run that. Okay. And it is not. I need to check which program we have. Whatever count should get asserted onto the bus by read. So if the read line, there we go. So now these two match if the read line is low. Let me find a wire for that. Let's see here. If I pull the read low, that will assert the bus, and it is. So our program count matches the bus, so it can assert the bus. So let's go back and check the programming of our state machine and make sure it's toggling everything correctly. Alright, we have a program now that takes the contents of the program counter and writes it to I/O, and then increments the program counter. That's all it does. It goes around and around and around. So we can see that we're counting correctly. And we are asserting the bus with the counts. We don't seem to be asserting all the lines though, which is interesting. So maybe all of these wires do not go where I think they go. Let me remove, turn the power off. Let me remove this. So I've removed the ALU, so I have some extra places to plug things in. Let me plug it in here. Let me see what that does. I need to reset it so we can start from, there we go. So, it's acting differently, strangely enough. Maybe not. Yes, it is. Oh. Depending on where I have it plugged in, it acts differently. That's very strange. If I have it plugged in here, the zeros digit flashes just a tiny bit, and then the rest of it's counting okay. If I have it plugged in up here, it's operating the same way. And if I have it plugged in up here, alright, make a liar out of me. Alright, so it's acting the same everywhere. Alright, so the next step is, let's look at the oscilloscope. Hopefully you can see that. Alright. So we're going to take a look at increment. And the increment is pulsing low once in a while, and I see a single pulse. So that seems to be good. And then let me look at PC read, which is the one that asserts the bus. And this one is weird. This one's giving me double pulses. That isn't right. Let's see here. Put on normal. There. See, it's giving me that weird double pulse. Why is it asserting the bus twice? That's not right. That's very strange. Let me remove this. PC read. PC read. Same thing. Okay, so it's not being loaded down. Very strange. Very, very strange. So, the state machine is not behaving correctly. And you can see we are still counting funny. Slow that down a bit. Oh. C. Interesting. I think it's counting more than 16 steps. I think we're not going round and round 16 steps here on the state machine. It's more than 16. If you watch the bus assertion, flash, flash, that's that double pulse. Flash, flash, that's the double pulse. But look at how fast the clock is going. So there should be only 16 pulses between the flash flashes. I believe that's a lot more than 16, so we need to take a closer look at the state machine and make sure that it's repeating every 16 instructions. Or if there's something else funny going on. Okay, I'm an idiot. Yeah, this has to go a lot faster because we have the two-phase clock. So we shouldn't be looking at that LED for the master clock. We should be looking at, that goes into pin 1 of the GAL. But the thing that comes out of the GAL is the two-phase clock, which is much, much, much slower. So that makes sense. Okay, so we're probably counting okay. It probably is 16. But we're getting that weird double pulse, so we have to figure out why we're getting the double pulse. I kind of want to put a logic analyzer on all the lines that we're interested in and kind of get a picture. It's a little cumbersome to do that, but I guess that's what we need to do.
Okay, so let's look at the state machine here. I did notice something funny on it. So we have this 4-bit counter. So it is counting 4 bits round and round and round, and those change address lines A0 through A3. And then the instruction that is loaded into the register affects the other 8 lines. And then the other lines are going to be held low because I'm not going to be using them. So A12 is being held low, and A3 or 13 is, whoops, there's no connection to ground. That's not good. If A13 is floating, it might be jumping between bits here and not giving us the correct thing. Now, this particular package that I have loaded on here is for a different one that we're using. It had an A14 and an A15, but I think it was a 512 device, but we're only using a 64-bit device. So, and it is a electrically erasable device, not a UV erasable device. So pin 14 is not used, and it is used in the part as a not write enable. So if you pull the pin 27 low, it enables the writing of this part. So I have it pulled high, VCC, and then pin A15 or pin 1 is a no connect. So those two are okay. So the only one that's wrong is this A13, which is pin 26. And here it is. So here's 28, 27. Those are tied together plus 5. And then we have this is 26 and it is floating. Let me turn on, yeah. So really this needs to be shorted out to the ground plane. So that might be our double pulse. So I will take a look at that. I will go ahead and put a bodge wire on here and ground this pin and see if things calm down, and we only get a single pulse.